Hey guys, welcome to part 2 of what is a set of videos I have on constructions. Like I said before, if you're looking for a specific construction, go to the description. I have timestamps and links to where I filmed specific constructions. So if you just need a refresher on one thing, go to the description. Alright guys, here is a set of two simple ones. We're going to inscribe a triangle in a circle, and also inscribe a hexagon in a circle. So just a brief description of what it means to inscribe an object. So to inscribe a triangle inside a circle, what I'm going to do is essentially draw a triangle, and all 4 points of the triangle, specifically a regular or equilateral triangle. I'm going to draw an equilateral triangle such that every vertex of the triangle hits the edge of the circle, or is on the edge of the circle. Okay, here's how you do it. Pretty simple. What you do is you're most likely going to be given a circle. Very rarely do they give you a blank page and say do it, but if they say here's a blank page, inscribe an equilateral triangle in a circle, draw out a circle and make sure to first draw the center point. You need the center point in order to do this. You're going to measure out the center point to the outer edge, essentially getting the length of the radius, and then start on any point of the outer edge of the circle. Place your compass point there. Okay? Just any edge. It could be here, here, whatever. And draw an arc so that it crosses the circle. Now take your point, go to that intersection point you just made, and another cross. And what you're going to be able to do is you should end up with 6 intersection arcs, I guess. Right? 6 points of intersection on the edge of your circle. So 4, 5, and 6. All right. And if you were to continue, that would be just about there. Okay, so all you're going to do is you're going to pick one point. You're going to skip the next point and connect it to this point. And this is for a triangle. For a hexagon, you wouldn't be skipping points. You just connect everything next to each other. So take this intersection point, connect it to not the next one over, but the one after that, like that. Okay, and now I'm not going to connect to this one. I'll connect to the next one after that. Right, so right down there, and there we have our connection. A little short. There we go. I'm a little short, so it's fine. I don't know, it's 5 cents short. Following that through, we have our equilateral triangle. Inscribing a hexagon, exact same thing. We got the radius. And now we do our little points, right? That's 1, 2, 3, 4, 5. That one a little large. And 6. And instead of skipping every cross, we just connect all the ones that are next to each other, all the adjacent intersections. So this gets connected here. This one will connect there. Super simple. This one connects here. And that goes there. Oh, there's 2 more. God. And yay, we're done. Almost dead. All right. So now we'll move on to the next one. Okay, so this next construction we're going to go through is inscribing a square in a circle. It's slightly different to the previous two that we've done, inscribing a triangle and inscribing a hexagon, regular hexagon in a circle, but it's just as straightforward. So what we need to do is first draw a diameter. All right, so it's going to be essentially a line where the two endpoints are the outer edge of the circle that goes through the center, right? That is the definition of a diameter. I don't really think I needed to explain that. Why did I? Anyways, that's fine. It's fine. So the next step would be doing a perpendicular bisector of the diameter we just created. All right. So you should be very familiar with this construction at this point. I don't really need to go through it too much, but you know, there's the first arc, not adjusting length. I create a second arc where the point of my compass goes on the endpoints of that diameter. And now I follow through by creating my perpendicular bisector. And this is a theorem that you might or might not have done, but the diagonals in a square are perpendicular, right? So if we imagine these are the diagonals, these must be the endpoints, meaning I just have to connect these and I'll have created my square. All right, guys, this is the end of part 2 in the video of constructions and the set of videos I have for it. Hopefully it helped you out. If you have any questions or comments, just leave them down below. If you're looking for the next video in the set, go ahead. I should have a playlist set up, or you can look in the description. Yeah, that should be it. Thanks for watching.